Check, 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 check.
Check.
Love being on the mic. Can I get everybody's attention just for a couple seconds before we start? Chris Marlowe. Jump up and down. Developers. I want to thank everybody for coming out to the fourth Achievers Tech Talk. I know it's a school night, so I'm not going to take too much of your time. Without further ado, here is Matt York, Software Development Manager at Achievers.
Zach. Great. Thanks very much, Zach. It's really great to see so many people here tonight. A lot of familiar faces, which is awesome. We're seeing people coming back, so people are finding a lot of value out of the Achievers Tech Talk, and let's keep it that way. So we're really excited to be presenting about web application security. You know, it's a big topic, and it's pretty gritty and technical, and you know, it's going to be a great night. So, but a couple housekeeping items before we start. We do have a MeetUp page. All the slides and the code from the presentation will be on there. As well, we also have Achievers Tech page. And tell your friends about this. We want to keep the events growing. We're actually, last time we were at 222. We broke 300 today, which is really exciting. So the Achievers Tech Talk presentations are really about us giving back what we've learned along our journey. So we want to keep it really fun, really informative. We want you guys to be contributing. We know there's a lot of smart people in the audience, probably smarter than me. So we want to keep people contributing their questions, their comments, and their experience to the talk. So keep that in mind. We also do have swag bags. So ask a question, you might get something cool. I'm not sure really what's in there, but it's got to be good. So a little bit about me. I joined Achievers in October of 2009. And I'm currently a dev manager, so I run one of the feature teams here at Achievers. Some of my past professional experience is doing web applications in Java, so J2EE, Spring, Hibernate. Also doing web applications with PHP and CodeIgniter, and also some BlackBerry mobile development, which I'm not that proud of. Oh, thank you. As well, I wanted to point out that I've been involved in the security projects, but there's also been two people who have been heavily involved. One of them is in the back there hiding. That's Kalen Proctor. Put your hand up, Kalen. Also around in the building is Eris Zakanthinos, who you guys have probably seen from previous tech talks. Really smart guy. Gave some awesome presentations. So hopefully he'll be around sometime, and they may jump in if there's some questions. So probably the really hard questions, they'll jump in there. So how many people have been to a previous tech talk before? That's awesome. It's almost everyone. It's really cool. But a lot of the previous talks have kind of told a journey and an evolution of Achievers and the stuff that we've encountered along the way as we've experienced this rapid growth. So some of the previous talks, you know, I've had things about scalability, the first talk Eris gave. Then we jumped into one by Zach, which was on PHP frameworks. I couldn't make it, but I watched the video, and it was amazing. Really liked that one. Back to Eris, you know, you get to a certain size, and database becomes the bottleneck in your application. You got to really concentrate on making your database perform. And finally, we're at security. So security is one of those things that comes up as you grow as a company, and especially as the customers you're dealing with also grow. So it's really nice to have standards and practices in place to deal with security questions as well as testing. So you may be audited, you may have pen tests from your customers, so it's really great to get ahead of that and really be prepared for what's coming up. So, I stole this slide from Zach. You may have seen it before. I kind of think, like good software, a good presentation is reusable and has reusable components. So I stole this one. I'm throwing it up here, but it's really there because we need to protect ourselves. So security vulnerabilities are on the rise. You hear about it in the news all the time. And you know, it can cause real financial and reputation damage to your company. So it's great you all here because it's increasing and it's on the rise, and got to watch out for it. So I thought I'd jump into a couple stats. I don't know how many of them are really accurate, but they're on the internet. I assume they're ballpark figures. Average cost of a damage, you know, $6.5 million. That's a lot. Next, this just shows the how many people are being affected by common web application vulnerabilities. Most people have probably heard of cross-site scripting, but I found it pretty surprising that this situation has actually happened to all of these big customers. Another interesting fact is that 70% of vulnerabilities are at the web application layer. So that's what we're going to be talking about tonight. There's many different facets of security. You got infrastructure, you have physical security. We're really going to be focusing on web application vulnerabilities. And finally, an interesting stat that 73% of organizations have been hacked recently. So I think a lot of people don't even know what's going on in their organization. They don't have the right monitoring tools in place. They're not even, so if there isn't any damage actually coming into your company, there are still people probing around and looking at stuff. So, the goals of the presentation. Number one, to not make the audience fall asleep. Security is a pretty dry topic. I see people smiling. I've been watching a few presentations recently, looking at slides, and I actually fell asleep in my computer the other night. So we're going to keep it, we're going to keep it interactive. We're going to try and get you guys involved and make it fun. The next thing is to teach you about web application vulnerabilities. So again, we're focusing in on web application vulnerabilities, not anything else. So if you have any questions, feel free to throw them out, but it's not my area of expertise, and maybe down the road we'll do another security presentation. So we're going to show you how to find web application vulnerabilities. So we're actually going to be diving into an application. We're going to be using a tool, and we're going to show you, how you can go through a site and find some of these common problems. We're going to demo the web application vulnerabilities. We're not only going to find them, we're going to show you kind of, real vulnerabilities that can damage a site. And finally, we're going to show you how to fix some of these vulnerabilities. So a lot of these web application vulnerabilities, I don't know how many people read the intro to the show tonight, but we're going to be going through the list of something called the OWASP Top 10. So OWASP is a great site. I included a link at the end of the presentation of some of the resources, but you'll see the word OWASP and a number littered throughout the slides, and that's just referencing back to that list. And it really is the most common web application vulnerabilities, so we're not going to be diving into the most bleeding edge, latest web application vulnerabilities. These are really just the core, most common ones that happen in the real world. All right, so the agenda. So I've created these two web applications, Super Secure Bank and smartattacker.com. So we're going to show you a little bit about these, what they're all about. Next, we're going to jump into something called Burp Suite. Has anybody heard about Burp Suite? Yeah? Awesome. What do you guys think? Good? It's okay? Good?
I didn't get to use it. It's not open source. It's a commercial thing.
Costs money, yeah, for sure. Then we're going to start testing how secure this bank really is. And if we find some vulnerabilities, we're going to help the bank out and try and fix some of them. Great. So, supersecurebank.com. What is it? It's the most secure bank around, all the wealthiest executives bank there. We're going to be doing a lot of our testing with somebody named Brennan Davidson. He's a high-powered executive. So it's really secure. It has some great features, and it has amazing UI and UX. It actually really doesn't, so I don't want to hear laughter about my HTML, my CSS. It's not the purpose of this. The bank's strong point isn't HTML and style and CSS. It's security, or it will be. Next, smartattacker.com. So this is a hacker's site. It includes some tools and pages for running exploits on other websites. Again, it has amazing UI and UX, and it really doesn't. So not their strong point either. Their strong point is stealing your money. All right, so Burp Suite. Let's start with some quotes. I will never develop a web application without Burp Suite again, and that was me. So there's a couple things I really like about Burp Suite, but it's not just that it's a security tool. It offers a lot of other great things. So it really gives you an eye into your application. It really shows you the flow of data going through your gets, your posts. When you're developing a web application, you can very easily kind of tell what's going on with get requests. Post requests are a little more hidden. In Burp, it keeps things very out in the open. It shows you the data flowing through, which is really great. Second one is I would spend my own allowance on this tool. Dr. Arasakantinos. Anyways, these two quotes are really just here to show you how much we like Burp at Achievers, and we really do encourage people to use it. So a little more about Burp Suite. I've kind of talked about it. It's a great tool for the money. It's about $300 a year, and it is really a good balance of, it's kind of a sweet spot of functionality to cost. There's a lot of really expensive tools out there, and Burp is, it's a reasonable price. I would actually spend my own allowance on this tool. So again, it's very good at finding automatically finding the basic vulnerabilities. And I don't mean basic in the sense that they don't affect other companies or they're easy to fix or easy to find. They're just kind of the common ones that you really want to get out of the way automatically with a tool like Burp. So that being said, it also has a lot of great features for doing manual testing. So like I said, it is a proxy. You can kind of capture requests and do a lot of the manipulation yourself. So do a lot of manual testing. And this is one thing to point out here is this is really where you want to spend your money on. So if you're actually going to get people to do work on your site and do third-party audits, you really want to get people to spend their time digging deep and finding the hard problems. So you don't want to have things that an automatic scanner like Burp can find. You want to really give them the challenging work, get your money's worth. So what is Burp Suite? So Burp Suite is a proxy that sits in between your web browser and an application. So normally you have a web browser, it talks directly with an application. When you fire up Burp, you have your browser, it's talking to the proxy in the middle, and the proxy is talking to your application. Does that make sense to everybody? Yeah? Awesome. So it's great because it monitors requests. It sits in the middle. You can stop them, you can replay them. Burp automatically modifies the requests and generates malicious attacks on the site automatically. And I mean, another thing that it points out is that client-side validation isn't good enough, right? So you can, with Burp, you can actually modify the requests right before they come into your application. So you're completely ignoring all the JavaScript, front-end validation. So this is really important. It really highlights the importance of really paying a lot of attention to your back-end validation of your data. And it also, applications are getting very UI heavy. You're seeing really rich, heavy UI applications with complicated things going on in the front end. And it really highlights that you really need to focus your final testing at the server level. All right. So let's dive into Burp Suite. I'm going to fire it up, and let's take a look. Is that showing up? So I'm going to do my best to bounce back and forth between the slides and the application and Burp, but some of it's a little choppy, so you may have to kind of question.
Yeah, is it only for Windows?
You just stole my first line.
Forgive me.
You get a swag bag.
Oh, geez, great.
If you do the presentation for me, you get free stuff. So, as Alfred said in the front row here, Burp is written in Java and Swing. So some of you may be cursing Swing right now if you've done some development. I've done a little bit of desktop application work in Swing, and it is kind of tough, but they've done a pretty good job. And again, it lets you run in any environment you want. A lot of you are on Macs probably, the cool kids. And Windows environments just works great on every environment. All right, so let's dive into the proxy tab here. So as we said, Burp is a proxy, right? So it sits in between your browser and the server. So what this interface is showing here is that on localhost, we're going to be running Burp on port 8080. So what we have to do now is we have to configure the browser to talk to Burp, the proxy, before talking to the web application. So we'll just quickly dive into Firefox here. Same kind of thing applies to other browsers. Networks, into settings, and manual proxy configuration here. We're going to pass everything on localhost onto that port 8080, which we're running Burp on. Sound good? Does that make sense? Anybody have any questions before we move on? No? Great. All right. So next, a little something in the target tab. Scope. So we have the URL of our application here. So you do want to make sure you're only testing the application that you're intending to test. You don't want to be firing off requests over to other applications. So this is important to check off, especially if you're doing active testing. So active testing means that you're firing off, malicious requests which could actually affect the application and do damage, or they're inserting data or modifying things, versus passive, which is just kind of scanning what's going on. Scanner is the main tab where Burp actually runs its own tests against the site, so we'll jump into that later. And another really cool thing in the proxy is this concept of intercept. So intercept is something you can turn on and off, and it actually just kind of intercepts the requests as they come into the application, into Burp. All right, so let's go into supersecurebank.com here, and we'll fire off a request. So you can see in the tab there that the spinner is just going and nothing's loading on the page. And we can see that Burp has started flashing and intercepted a request. So that's exactly what we were talking about, being a proxy and being able to intercept requests and stop them before they go onto your application. So some interesting things happen here. You can kind of dive in and see requests and responses, which is great. As well, you can, sorry, I'm looking for one thing here. Target. We're good. It's not behaving here. Anyways, let's just fire off that request. So if we forward it on, we can see that the request went through. Now we're getting a request for a CSS file. But now we have some requests over here. So we're now on the domain supersecurebank.com, and we can see actually the requests and the response data. So the first thing we want to do is actually just check out what response came back from the server. So we can see we have a session cookie, and we have a few other headers sitting around there. Does anybody notice anything off the bat that they don't like about this response coming back from the server? For a swag bag. It's good stuff in there. USB keys, headphones, stickers.
Server info.
Sorry?
Server info.
What do you mean by that?
Well, it shows your server configurations and all the information you're running on it.
Awesome.
I'm okay with that.
You're good? Okay. You get a new t-shirt once a week at Achievers? All right. So we're going to jump into the slides for a second again. I'm getting a little better at this, switching back and forth. All right, so the first tip is don't give away too much information. So you saw, like Chris pointed out, we had two headers there that were returning information about our system. One of them said we're running PHP. I think the other one said we're running Apache. So this is a bad thing to tell people. It's a bad thing to tell attackers because they'll use this information to kind of narrow down their attacks, right? So if they're going to be scanning your system and trying vulnerabilities against PHP systems, Java systems, all over the map, this will make them get into your site faster. So you want to make sure you turn these things off. So sorry, go ahead.
So I'm currently going through this exercise
Yep.
For one of my customers.
Awesome.
And one of the points that we had in a penetration report was this very thing that there was too much being given away in Apache and
Yep.
the version number and so on and so forth. We couldn't completely eliminate Apache.
No.
As small as you could get it. You couldn't eliminate that response header. Did you guys find a way?
Yep. Yeah, I'm pretty sure we did. I'll follow up with you and send that to you at some point. Maybe put it on the Achievers Tech Talk notes. Sorry, what were you saying, Zach?
Can you repeat the questions that they're asking?
Oh, repeat the question. Sorry, so Alfred was talking about getting rid of an Apache header from the responses. So basically how you do this is there's configuration in Apache and there's also configuration in PHP INI on how to turn these things off. I'll post that on the notes. question. Anybody else while we're stopped? Nope. Cool. So while we're on this topic, there's also another thing about not giving away too much information. That's verbose error messages. So all of you have probably seen unexpected errors in applications. Sometimes you get a stack trace. Sometimes you get a funny picture. But you really want to keep these messages as generic as possible. You don't want to have a stack trace. You'll be able to tell it's Java or it's PHP or something like that. You want to keep it as generic as you can. So if you have an idea about what really happened to the error, display a user-friendly message about the error. If you have no idea, it was unhandled exception, you really want to just display a generic message. You don't want to give any users more information than you need to about your system. Yep?
If that big long error message isn't being spit out visibly on the screen, is it still being sent by the server to the browser?
What do you mean by on the screen?
If I'm not seeing big long error messages pop up on the screen, as I've seen sometimes,
Yep.
could my server still be sending that message along and just not be interpreted?
Not likely. So normally, it's usually in the HTML. So if you're not seeing it, it could be in hidden HTML. I've seen that before, which doesn't really do much. So you really just want to make sure that it's nowhere in the response. So I would doubt it would be in a header or anything like that, but you want to make sure it's not showing up on the page. Cool. You can. It's a bag for you. All right. So that's pretty self-explanatory one. And I just jumped too far ahead. All right, so let's jump back into Burp and let's take a look at the home page. So now what we're doing is we're basically turning on the scanner, and we're going to see what Burp says about our home page. So right away, Burp has given us some instantaneous good feedback about our website. So all of these vulnerabilities listed here have really good descriptions in Burp. They actually give you a good explanation of what the exploit is, as well as how to fix it. So some good ideas. So from the top, the ones in red are the really bad ones, down to the orange ones, which are still pretty bad. You want to take a look. And the eyes are information, but they still could lead to vulnerabilities, so you do want to take a look at all of them. So we're in a moment, we're going to jump back to the slides, and we're going to kind of deal with all of these. So just wanted to kind of briefly talk about them. So clear text submission of password is talking about HTTPS. We'll talk about a little in the slides. Password field submitted as a GET request is just really talking about if your form is doing a GET request or a POST request. Password field with autocomplete enabled. Do you guys know about that? People seen that in HTML? So you can have an attribute on there that says autocomplete equals off. If you're storing sensitive data in your browser, that's kind of a bad thing. So usernames and passwords are actually, can be stored in the browser. Somebody else can use your computer and get at that data. And then on to one at the bottom that's interesting is frameable response. So clickjacking. Has anybody heard of clickjacking? It's kind of a rare one. Nobody? If you put up your hand, you might get some stuff. No? All right. Awesome. So let's dive into these. So the first thing we saw on that page was to do with HTTPS. So HTTPS is for protecting the transmission of sensitive data. So we saw on that password form, we were basically just transmitting the user's username and password in clear text. Obviously, that's a problem, right? Anybody sitting in between, anybody listening into the data can see the password in clear text. So what we want to do is we want to make sure that any sensitive data is transmitted over HTTPS. That being said, HTTPS isn't a silver bullet. A lot of people kind of get this weird idea that you throw your site over HTTPS and all these vulnerabilities magically go away. That's really not the case. Everything that we're presenting in the presentation tonight, all the vulnerabilities are still applicable to HTTPS sites. Next, kind of a side note about session cookies. So a lot of sites, everybody knows how you log in, you get a session, and your session is passed along as a cookie. So this session cookie is what binds you to an authenticated session, right? You only give your username and your password once. This cookie travels back and forth and keeps you logged into a system. So it's kind of important to note that if your site isn't over HTTPS the entire time, you are vulnerable to session hijacking. So what that means is your cookie traveling back and forth over an unencrypted channel is picked up by somebody else, and they insert it into their browser, and then they're into your session. So a lot of sites do this. They do SSL for sensitive data, and the rest of the application is over HTTP. So there's some couple ideas around sessions that I wanted to throw out. I mean, it's great if you throw your entire site over HTTPS. You'll see banks doing that, but sometimes it doesn't happen. Session cookies, a couple interesting things you can throw into them are things like user agents, IP addresses, things like that. So something that kind of gives something unique about the user. Then you would encrypt the cookie, and then the attacker basically can't modify it, right? So if they're attacking you with a different browser, they wouldn't log in. If they were attacking you from a different IP, they wouldn't be able to log in either. Does that make sense? Any questions?
How do you do it?
Sorry?
How do you do it?
What do you mean, how do you do it?
Just add it to the session. Just add the agent, browser agent, what it is, and it comes in, and then it verifies it. Yeah. We can make a string of it.
Yeah, exactly. So you have a string of data. One of the items in your session cookie is normally some kind of ID, which links your user session, your user to a session. Other pieces of data can be, so a user agent, IP address. Then you encrypt it all.
We'll take it off.
Or
Yeah.
you could, without having to type in the password again, you just you can verify the username and password again each time.
Yeah.
But a lot of usernames, a lot of passwords now are kept in databases as encoded string.
Yep.
And you can manipulate that any way you want.
Yep. So we'll
Verify it back and forth. So
yeah. I mean, it's not usually not the best practice to keep passing along usernames and passwords.
because nobody puts
Right.
the password anymore, that's the password that's entered.
Yep.
That's never kept in a database.
For sure. I like the participation here. Let's see some comments from the back. Eris, you got anything? Oh, thanks. All right. Another thing to point out is not all HTTPS encryption algorithms are equal. Right? So everybody's heard of SSL, you have TLS. There's different versions of these. The older ones are less secure. So you really need to think about what your customers need and turn off the ones that you don't need, right? So don't even let your servers respond to those kind of negotiations. Make sense? Awesome. So this was a password form, right? We didn't really dive into the details of it, but one thing you need to watch out for is brute forcing, right? Does anybody know what brute force means?
You do a dictionary attack and just hit your server with every possible combination of common passwords.
Exactly. So very easy to do in a tool like Burp. You just keep cycling through common usernames and passwords until you're into the site.
So if you see your server has like 12,000 requests from one IP address in one afternoon, you know that someone's brute forcing you.
Exactly. So the guy in the front said, you see a whole bunch of IP addresses coming into your servers on one day, you can tell it's probably somebody trying to do something like that.
But you can also stop it easily by allowing only 3 attempts and shutting out that address for 24 hours.
Thank you for doing my presentation. No, so guy in the second row brings up a great point. That's the kind of thing you want to have on your password forms, right? So you want to keep track of how many failed attempts have happened and eventually go into some kind of state where the user can't keep logging in for a certain amount of time, or they have to go through an email, kind of unlock their account. It's a great point. So yeah, we bring it up there too, password policy. So that would be a kind of password policy. Another thing is like minimum characters. How secure do you actually want your passwords to be? If all your passwords are one character, somebody's going to be able to guess them really easily. Another thing to take into consideration is what kind of data do you want in there? Letters, numbers, symbols. You guys have probably seen on some sites, as you enter a password, you'll see the strength bar kind of go up. So you can't have policies where people have to actually enter in all of these things, right? Makes it stronger, good thing to do. Next point is, do you have a good strategy if you get into a bad situation? So a lot of people talk about security as just being find vulnerability, patch the vulnerability, right? But what do you do when something bad happens and you need to recover? So you need to think about these things. An example of this is, what happens if your passwords do all get captured, right? What do you do? Anybody? From the second half of the auditorium. Ladies in the back. All right.
I'll take this but from a different angle. I would say that usually you don't store the password, you put salt, you store that too. So
Yeah. Cool. So we're going to get there too. But kind of what I'm looking for here is you have a policy where you know something bad happened and you want to go into some kind of recovery mode. So like you're saying, yeah?
You disable the performs until you find out the root cause, and then you fix the problem, and then you
Yep. So you either go into lockdown mode until you can do more information, or you kind of you null out all the passwords. You reset the passwords, you generate emails out to users with, reset your password kind of links, stuff like that. For you. Oh, front row, yeah. I'm sorry, you've said like 5 things I haven't given you. Hopefully that's got some headphones. So somebody mentioned hashing, or turning this clear text password into something in your database that isn't recognizable by a user. So all of these acronyms up here are hashing algorithms. So they're one-way functions where you take something like a password, like hello, goes through this function, and it turns it into something completely unrecognizable to the user. So why is this a good idea?
Because there's no way to get back to the password.
Exactly. It's a one-way function. So if somebody captures your database, they don't necessarily have what they're going to type into the login form, right?
Of course, the hackers have tables now for all this.
You should get up here. You're good. This guy knows his stuff.
So that's already compromised a bit, but it's still the only thing.
It's good. Yep, in the back.
Should you also be salting these hashes with the registry? No.
What is salt and pepper? Give us a definition of a salt. Banned from the 90s. Yeah. Push it. Do you want to try and tell us what a salt is? It's kind of common.
It's a key that you add to the
Yep.
to the hashing of the.
Cool. So, we talked about hashing passwords. If Alfred and I had the same password, and we were using a hashing algorithm inside the database, say we used MD5, our 2 hashes would be the same. Guy next to him, sorry I don't know your name, mentioned something called a rainbow. Paul in the front here mentioned rainbow tables. Does anybody in the back over there know what a rainbow table is? Want to tell us? Lanky in the back.
It's just a multiple sequence of hashing. You make different hashes in different tables and keep hashing it multiple times.
Cool. So you take, basically what you do is it's tables of known kind of common passwords and their hashed values. So attackers will use the hashed value to look up the password. That make sense? Cool. So we started talking about, sorry, Zach?
Just before you go any further, you mentioned a whole bunch of hashing algorithms. Is one algorithm more secure than the other one?
Definitely. That's something to take into consideration. Things like SHA-1 and MD5, people are starting to crack those pretty quickly. Yep.
One thing you can do to protect against that is you can hash it and then do things like reverse it and chop stuff off or take the middle. You create a whole new hash. It won't ever exist on somebody else's table. You'll never have a table.
Yeah, it's true. So that's kind of what salting and peppering is about.
Salt is good.
Yep. So, sorry, another question in the back.
I'm having trouble following the flow from the questions and answers.
Yeah.
Could you just say how hackers are penetrating password right now and how to protect against it?
Sure. So
I get salting.
you get salting.
How are they cracking MD5? How to protect against that?
Really smart people with fast computers. Computers are fast now and can do a lot in a really short amount of time. Eris, do you have anything to add on there?
Yeah, I think a lot of the items that you're seeing, there's theoretical exploits. So sorry, I can't see that. There's theoretical exploits where somebody believes they found a vulnerability and nobody really knows how to exploit it. And then there are real, honest to goodness, yeah, we can break this thing. So when you're reading things in the press, you really need to figure out which one of the two it is.
Yeah.
What Matt's talking about, there's a lot of databases out there where if you use MD5, you give me your hashed MD5 value and I can give you a password. And that is a instantaneous free lookup. So it doesn't even have to be that MD5 itself was broken. It could just be that because MD5 is used so often, we hackers put together massive tables for you to go and look up stuff.
Yep.
So just be careful when you're reading that you don't want to confuse the two because there are theoretical exploits against a whole bunch of things that there are no practical ways.
Yep. Great point. Thanks, Harris. That being said, though, SHA-1 and MD5 are cryptographically less secure than things like bcrypt. So that's something to take into consideration and look at. So the salt in there, we'll go back to the salt for a second. So a salt is a user-specific thing. So we talked about rainbow tables. If we're adding a salt, we're actually putting a user-specific piece of data inside with the password before we run the hashing algorithm. What this means, if Scott and I have the same password, the hashed value in the database for us will be different. So it's harder to use things like rainbow tables, right? Hash, yeah. So Pepper is something that's per system. So this is something that usually lives outside of the database. And it's also, again, in the diagram there, it's appended inside before the hashing happens. So one interesting thing about this is if somebody picks up your database and steals it, they're missing one of the pieces of the puzzle because it's not actually stored in the database. So salts are usually stored with user records.
How's it accessed?
How's it accessed? So usually it's part of your application, maybe stored in a config file somewhere.
Private files.
Yeah, and brought into code.
Outside of the web.
Yeah, sorry,
Have you ever
question.
seen anybody modify the salts for every user or the pepper for every user?
So Pepper isn't per user
No
system?
peppers for the system, right? But for salts, can you do an algorithm where you modify the salt for every user?
Modify the salt.
Some characteristic of the user.
Well, yeah, in WordPress,
Well, that's-
for example,
Yeah.
you select a number of different salts for different things. When you put your application up on the server, you've already selected in the configuration file
Yep.
your own salts.
So there's really, the way you generate a salt is basically is like per user. So it has to be unique per user, just different.
Each user generates tangent.
All right, so we're going to move on to another thing we saw in there, which was to do with iframes. Oh, sorry, question?
I was just waiting for one thing to come up.
Yeah.
To jump on the gun before.
Go ahead.
On the topic of brute forcing, probably captcha would be a good thing.
Yep. I'm going to get to that later on another brute forcing slide, but that's a great point. Pass that back. Sorry, another question?
Just on the picture that I understand correctly. For example, assault would be the password and adding the first letter of the username.
Yep, good example. It's a very basic one, but that works.
It would have to be something that you can't change on the user table. So if like a user
Okay.
Throw that back to that guy. Cool. Okay, so on to iframes. So allowing your site to be hosted in an iframe has the potential for people to be able to do things that they didn't intend to do. So what I mean by this is on a web page, you have an iframe, you have your application running inside, and somebody can put something on top of that iframe and trick you into doing things. Make sense? iframe sitting there, people are clicking, meaning to click on some ad for an iPhone, and they're really clicking on the underlying iframe of your site, doing things they didn't mean to do.
Sorry, what's the danger again?
So this is the one we saw as clickjacking before. So it's basically getting clicks into the site that people didn't intend to do. So it's a rare one. It came up as an I on the list. Remember that? Yeah. So you have an iframe. You know what an iframe is in a web page?
These are using, that's how we set up an advertising program
Yep.
for a time. We just did that. And the page is in an iframe. You click on that.
Yep. So this is one of those. So the danger is just that somebody takes your site and uses it in a way that you didn't intend. They host it in an iframe.
Oh, I see.
They put something over top, which makes you want to click on that something, but really you're clicking underneath on the iframe hosted site. So it's a weird one. It's not that common. It's not usually that malicious, but it does happen. So this is one of those things where it's like kind of a trade-off between usability of a site and the real security. So do your customers need to host your site in iframes? If they don't, you might as well throw in this security. So one of the ways to prevent iframing is to add a header called iframe options. So you can add options here to completely deny or from the same domain. So you can only host your site from your site in an iframe.
And when you say deny, you're talking about an HD access file?
No, so this is a header, and it'll completely block. The browser will not load the site. So this is available in most modern browsers. It's not there in some of the older ones. One thing some people do is called frame-busting JavaScript code. So this is code that runs in your site, and it actually will break your site out of an iframe into the main level browser window. So it is circumventable, but the best thing to do is just have both of these in place. Yep.
Just curious, with clickjacking, I've heard of it with somebody had a little hack or whatever on Twitter once where they gained 1 million followers because they got people to click the follow button without being seen.
There you go.
Somebody did a Facebook, Walker sacrifice using Facebook app just to unfriend
Yeah.
your friends because it wasn't available through the API and just find a way to do it that way.
Yeah.
Do you have any examples of it? I mean, the Twitter one was against terms of service, most likely, and stuff, but do you have an example of a really malicious
I can't think of one off the top of my head that I've heard of. I mean, yeah. So that's yeah. That's probably why it came up as an I. Sorry, Eris.
So why I don't have an example, I think one of the reasons you don't see very malicious ones is because anything that's super sensitive, like your bank account, would already have taken care of this issue. So we, for example, do third-party security audits, and on any page that doesn't have this option set, you get notifications saying you need to set up this page. So we're doing it, every bank is doing it, so they're getting the same inputs that we're getting. So the reason you're not seeing a lot of malicious content is it would get flagged.
Yeah. Try it out. It's not going to hurt anybody. Take a web page, put an iframe in it, put your favorite bank URL in there. You probably see it won't load. If it does load, send them an email. For sure.
There was one for you recently. And offer your consulting services.
Yeah, and then get a job. Yeah.
There was one for you recently with Facebook likes. So if you were logged into Facebook, it would then show Matt York like reallydirtyporn.com or whatever.
Yeah. So again, all the examples are really kind of low impact, but they're things that happen. So it's people gaining popularity, people just getting a lot of clicks on one thing. All right, so let's kind of dive into the site now and take a look at some of the features once you log in. Just going to turn off the scanner for a second. All right, so here we are on the login page. Nobody's really commented on the beautiful UI yet, but I hope you're enjoying it. So I'm going to log in as Brennan Davidson here. No? Shit, sorry guys. Nope. Sorry, I totally forgot my password. I'm going to dive into the other... Sorry? It is super secure, yeah. My password automatically changes every day, and I don't know what it is.
I'll tell you, give me 10 minutes.
So I'm going to dive into the forgot password functionality. Pretty common in sites. What do? You enter your username, Brennan Davidson, and you go ahead. Oh, sorry? Oh. Oh, good catch. So it told me, yeah, I made a typo there. I can't find my username. So, there we go. All right. So I got my password. load up my email browser, and away we go. So does anybody see any problems with the things that just happened on this page? All kinds of hands.
It sends you the password?
The Achievers devs can put their hands down. Let's go with somebody in the back half. Right there. Yeah.
You need to fire your web dev.
I need to fire my web dev?
Yeah.
That was, I built these applications. Was that it?
No. You're essentially, so for example, the login page, every single time you prompt the user, you're actually displaying the results from the last one. So you're not, that's not necessarily bad, but you shouldn't do that because it's just conveying too much information.
Yep. So what should you do here?
You should just not accept it or not even talk about it.
Sorry, what do you mean?
You shouldn't respond back, or you shouldn't display the text that's coming in.
Yeah.
You could do potentially like a script inject. Right?
Cool. So there's something else on this page. A couple things.
We are saying whether the user exists in our database or not.
Thank you. Good eyes. Do you already have a swag bag?
Yep.
All right. Do you want another one?
No.
Okay. All right. So great point there. We're telling people if usernames are valid or not. So this is back to like not giving away too much information. You want to hide whatever you can. So the right thing to do here is to give a really generic message. If your username was found in our system, we emailed you your password. The other thing wrong with the page is the end of that sentence. We emailed you your password. That's usually not good practice either. Email is pretty insecure. Email also sits in people's user box, and it would have their password, right? So the right thing to do there, sorry, go ahead.
And it means that you're holding the password in clear text.
Good point. No fooling you. Right?
So what are you going to enter?
Sorry.
What are you going to enter when you forget your password?
So that's a username there.
Huh?
That's a username. The field there?
Well, I thought somebody said not a good idea.
Well, it's not a good idea to email back passwords.
Oh, sure not.
Yeah.
You need like a link to change your password.
Yeah. So Alfred brought up a good point that would also mean that we are storing our passwords in clear text in the database. Because remember we said the hashing functions were one way. So user enters their password, hash it compared to the hash value in the database. If we need to send a user a password, we can't do that. All we have is the hashed value. So great point.
Why don't you just ask for their email address instead of the username?
Same thing. So basically, if you're using a username or an email address to log in, we don't want to tell people if that's actually a valid username or email address, right? If that's one half of your login combination, you're giving away part of the puzzle. You know what I mean?
Yeah.
Cool. All right. So quickly jump back to the presentation here. Slides. So we talked about that, account harvesting. Don't give away too much information. You're getting usernames out of this process. It's another place for, go ahead.
How do you avoid that? How do you tell the user whether?
So you don't. You give them a generic message that says, if we found your username, we emailed you. Or you just say, we emailed you.
Or just we emailed your password.
Yeah. Right?
If I forgot my username,
Yeah, it's annoying. So this is, again, another one of those things that keeps coming up is trade-offs, right? So it's a trade-off between usability of a site and security. Very closely related.
I have a bank who forces me to change password every 14 days.
It's probably a good bank. It's kind of annoying, but it's keeping your money safe, right? Yeah. Well, I'll take your money in supersecurebank.com if you want. All right, so somebody mentioned CAPTCHAs before. Can somebody describe what a CAPTCHA is? Yep. Cool. So it's one of those things you see on web pages, the really annoying picture. We have to type in the letters of what the picture is. That's called a CAPTCHA. So I put up the acronym here because most people don't even know what it means. They just walk around talking about CAPTCHAs. But it's a useful thing to stop brute force attacks here. So it's another place where you could have a tool just firing off common usernames until you found you had that response back that said we sent you an email, and that way you have a username. If you have a CAPTCHA in place, you can't just write your own what?
CAPTCHA.
Write your own code?
Or you're using the generic one that everybody uses. It's
Yeah.
impossible to read anyway.
Exactly. So there's a lot of CAPTCHAs that I have to guess like 10 times. But there are just common libraries out there with parameters to make them easier or harder. So definitely one thing you can use in this situation. So we've explored two of the unauthenticated pages here, and I wanted to just take a second to talk about the difference between main difference between these unauthenticated pages and your authenticated pages. So the main difference here is anybody can access these pages, right? You don't have to be a member of the site. You don't have to actually log in. So it's really important that you focus a lot of effort making sure that these pages are secure. Make sense? Cool. All right, so let's dive into some of the features of the sites. All right. Now that we have our password from the email, Brennan Davidson. We're going to log in. So some awesome features in this bank. First of all, feedback. The bank stays on top of things and cutting edge by getting feedback from the users. You can go in and see your account balance. You can update your address, and you can obviously log out. So let's dive into the feedback, see what that's all about. So I'm going to turn the scanner back on, and proxy's off. So let's dive into feedback, see what happens. So nothing much really coming up on this page. Just some basic information type issues. So let's dive into this form and tell the bank something we think about them. The bank is really great and secure, we hope. All right, going to throw that in, see what happens. It's taking a long time here. Demo fail. That's why I should have had a video. Oh, there we go. So we can drill into our pages here in the results, and we can see something that people have already talked about called cross-site scripting. So who knows what cross-site scripting is? Anybody in the back?
It's when you access a form, not using that form.
Yep. Access a form, not exactly. Anybody else have some sort of definition? Go ahead.
It's when you can inject JavaScript or other data that wasn't meant to go in there. But JavaScript is generally the
Awesome.
thing that you do. And then once you've got that, you can do anything you want with that page.
Exactly. So XSS enables attackers to inject client-side script into web pages, which other users then go and view. So a typical example of this that you see sometimes is an alert, right? So you're browsing around on a web page, an alert pops up. Kind of annoying, but there are other things that can happen with cross-site scripting, so things that can actually cause real damage to your application. Things like storing session data, session IDs, things like that. So we're going to kind of dive into the application again and actually demonstrate a really malicious cross-site scripting vulnerability. So I'm just going to cancel the scanner to make sure it doesn't get in our way. Turn things off. Jump into feedback. So we can see this alert here is actually what Burp injected there. And that's what told us that it could actually, execute a successful XSS. Right? So this gives us a good list. You can see here all this data. This is actually Burp being in between the browser and the application, taking a request and then modifying it and replaying malicious attacks. So same URLs, but changing the parameters, changing the data. Make sense? I'm going to clear all that out just for make it easy. Right. So very quickly, we'll show just another kind of alert. So this is what the script looks like. This is something that you normally don't want users to enter here, right? Normally, you just want basically some text, so text characters. So that's great. That's annoying. But what else can you do with this?
Can you inject any PHP code through that onto the server? Replace the file names?
Probably not. I mean, it depends. So this is usually going into your, either being echoed back to the page, so that's called a reflective cross-site scripting attack, or getting stored in the database. So it's usually pulled out and put into the HTML page. So yeah, maybe you could put some PHP tags in there and execute things. All right, so I'm going to throw something completely random in here, fire it off, and see what happens. So we added some feedback, great site, love the security. We also injected an image into the page. So this exploit, you normally would hide the image. You'd use like a 1-pixel image or a clear GIF or something like that. But I just wanted to show what was going on here. So let's take a little look at this, this code that I injected. So it has a script tag. So that's why it's called cross-site scripting. And basically what it does is it appends an image into the page that references another site, right? So the image is coming from a different domain. This is exploiting the fact that images can be loaded from different domains, right? You can build a website, grab a bunch of images from different websites, and load them on your page. And then it's also in the URL. It's passing on a parameter that's calling a JavaScript function called document.cookies. So what it's doing is it's loading an image in the page and actually passing your cookie data over to smartattacker.com. Does that make sense? It's kind of a point to ask for questions, I think. There's a lot going on here.
Can you go back to that script?
Yeah, sure.
Does that allow someone to hijack your session?
That's exactly what's happening there, yeah. We'll get in there. That's the session cookie we saw in the request in the beginning. Anybody else? Ladies talking in the back. You get what's going on? Yeah. I know they work here. They have no clue. All right. So our vulnerability there. Let's go over to smartattacker.com. This is the other site we talked about. And check out the cookie page. So we can see a big list of data that's come in from that URL in the image. And we can see at the bottom here, 736, we've actually grabbed the session cookie. So I'm going to actually take this cookie. I'm going to take it over into a different browser. I'm going to demonstrate to you that we're not signed into this site. I'm going to grab the little cookie plugin here. Going to submit the cookie change, and I'm going to be logged in. Hold for applause. So has anybody actually seen an XSS exploit before, performed?
That was XSS exactly. Well, that was session hijacking.
Yeah, exactly.
So I hadn't seen session hijacks.
Good point. So it's a combo. It's two birds with one stone. So we got an XSS attack that actually stole a session. So that's called session hijacking. I just think it's interesting. I've seen a lot of demos before, a lot of presentations where people have like animated GIFs showing you kind of what's going on in an XSS attack. So I think it's kind of cool to actually do one. I don't know. There wasn't a whole lot of clapping, so I guess not. So back to the slides for a minute here.
So what's that plugin? And is there like a similar one for Firefox?
Yep, so the plugin was just simply a cookie manipulator. So I think in even Firebug and Firefox you can manipulate cookies. Web developer toolbar, all kinds of toolbars. Yeah. So back to session cookies. So Alfred mentioned session hijacking. So one of the things to point out about those session cookies here is there are ways to make that document.cookies JavaScript that we use to pass the cookie onto the image URL go away. So there's something there called HTTP only flag. And what that does is it makes it so the only thing that can actually access your cookies are HTTP requests. So that whole document.cookies, if you set this flag on your where you're setting cookies in your application, it would come in as blank data on the Smart Attacker website. So pretty cool. A lot of good stuff there. Another thing to mention while we're talking about cookies is a secure flag. So this is for sites that are using HTTPS. If your entire site is over HTTPS, you should mark all of your cookies that you want to keep secure with a secure flag. What it means is if somebody somehow gets onto an HTTP URL, that cookie won't actually get sent with the request. So you're going over to HTTP where people can, see your cookie and hijack that, and it's actually dropping it. It's a very good flag to put on your site. All right. So into preventing the actual cross-site scripting attack. There's two phases to this. There's two things you can do to prevent things. One of these actually prevents it by itself, but it's really good to have both of them in your application. If you ever miss one, you'll have the other one, having your back. So we're going to talk about these two. The first one is called output encoding. Does anybody know what output encoding is? Yep.
Just converts all your less than greater than symbols which can inject JavaScript in your page.
Perfect. Yeah. So this exploit actually happened from script tags being executed in your page. If you actually encode those script tags, the angled brackets that make up the script tag, they'll actually just display in the page, and they won't get actually executed as JavaScript. Everybody follow that? Cool. All right. So we're going to kind of jump. Actually, let's talk about XSS filtering right now, and then we'll jump back into the application. So XSS filtering is the other side of the equation. So why would you ever let those script tags get onto your server? Or why would you ever process them and put them into the database? You're basically just asking for text from the user, right? So you have that text box. All you want in there is a nice little comment from your users. So XSS filtering is the idea of filtering out any input that isn't required for the data. So say, sorry?
Making a waitlist, script with a waitlist?
Yep. Good point there. Whitelist is the way to go. You don't want to do a blacklist. Too hard to keep up with different vulnerabilities. People come up with new XSS exploits. It's better to actually tell people what they can put in, right? So if you're allowed to use a bold tag, tell somebody they're allowed to use a bold tag, right? But everything else will get blocked out. So good point. This is really just a subset of really good data filtering on your server. So think about things like integers. In your application, you're wanting an integer value passed onto your server. You want to make sure that you're actually getting the data you want, right? So you can run an XSS clean on that. Another way, more efficient thing to do is something like an int cast. So you're actually getting rid of all the data that you don't want and you didn't intend the client to send you. Everybody follow that? Harris, you following along?
Yeah, I'm following along. So the only thing I'll point out is why you need both. I think it is, as Matt said, one or the other, both work.
Yeah.
But there are some really, really, really smart people out there that have bypassed output encoding. You think, well, I'm encoding my angle brackets. How could anything get through? Well, unless you manage to figure out angle brackets in every single character encoding on the internet,
Yep.
somebody is going to sneak something through that output encoding. So you need both lines of defense.
Yep.
And ideally, both lines of defense come from different vendors so that they don't have the same bug.
Good point. So this is one of those things, too, where you don't want to be writing it yourself, right? There's lots of good implementations out there. They're hard algorithms, right? So don't go reinventing the wheel. Go with something that's proven and tested.
You'll get it wrong.
Because you'll probably get it wrong. It's more complicated than you think. It's probably a good time to mention, too, that XSS filtering can be expensive. There can be serious performance implications. So it's not just a simple algorithm that cuts out, like, certain angled brackets here and there, certain combinations, the word script. It's actually a very intensive algorithm. So you're kind of looping through characters. You're applying complex algorithms at kind of multiple stages along the way. So you should be careful with it. You shouldn't just jam it on everywhere. If it is actually an integer, actually treat it as an integer. Don't apply a text kind of filter like XSS. Does that make sense? Cool. All right, so another thing to mention here is there are headers. There are XSS headers that browsers are starting to come out with. They don't work in all browsers. They're a good thing to throw in there. I know Microsoft has one. I've heard mixed reviews of how it actually works. But you will get dinged by security testers on it if you don't put it in place. But don't trust it. You can't trust it in old browsers. You can't trust it in all browsers. So you do need to have output encoding and filtering in place. All right, so we're going to jump back into the application for a bit. Let's see here. Actually, just going to clear this stuff out. Does anybody have any other questions while I'm getting set up? No?
Yeah, earlier on, I was just wondering, when you did the injection script, you had the image come in with jQuery, and I was just thinking, like, a hacker would have to know that the jQuery library was installed, right? Wouldn't they just do it in pure JavaScript just to be safe in case, like, jQuery wasn't installed?
Yeah, I'm just lazy.
Okay.
Good point, though. Thanks for pointing that out.
Also look at your page, right? So if they can actually see what script tags you have on your page, so they can actually leverage your own infrastructure to execute the attack.
Good point.
You can also just pull in jQuery from Google.
Yeah, I was just about to say that too. Scott's a smart guy. So script elements are one of those things where you can actually go cross-domain too on a page, right? Images, script tags, load up jQuery, and away you go. Cool. All right, so we're going to dive into the code a little bit and show how to kind of filter out, do output filtering. I'm losing my words here. How to do output encoding and XSS filtering. All right, so first off, we're going to go into the page. So we're going to go into the feedback page, and we're actually going to use a function that does what we're talking about. So it actually encodes the bad data. We're using a library. We're not writing our own. Where are we here? Feedback view, feedback data. I'm in the wrong place. What am I doing? So here's the element where we actually are displaying that feedback data. So we're going to grab this function that we have that's called encode HTML. We're going to wrap it in there. And put the file type.
Built-in file type to help you be able to inspect the file and give you the line type that it thinks the file is. Not perfect, but pretty.
Not perfect. Not perfect, better than nothing. I put up here /////. Everybody knows what that is. You're kind of walking up a directory, right? So you want to be careful if you have paths and file names in your system that you don't let people get those files to places they shouldn't be, right? So you want to always convert that to a normalized form, an absolute path, and make sure it's actually where the user should be writing data. Third one there we kind of talked about, don't email out passwords. Pretty obvious. Email's pretty insecure. Set content type headers, an interesting one that you see everywhere. People love to use echo and PHP, and you're basically there just echoing out data. You're not actually telling the browser with a content type header what type of data it should be expecting. So there are fairly sophisticated vulnerabilities around this in some browsers. I know particularly in IE it's more prevalent, but there can be attacks done on how the browser actually tries to figure out what content type it is. It's also probably faster for the browser to actually know what content type you're giving it, so just always set those headers. And also validate your redirects. That's a big one that's on the OWASP list too. You've probably seen forms where you go through a login form, you click on something like feedback, bounces you back to the login form, and you have a little question mark, source equals /feedback, right? So that's great. You're going to log in, you're going to end up on the feedback page. But what if somebody puts another site in there? What if you allow it to be an absolute URL? People can get actually tricked, so you can be on a bank and get tricked into going to a site that looks very similar to a bank. So there's something called phishing. Didn't really get into, but a big vulnerability. And people can enter sensitive data there. They can go to a login form and enter their username and password, intending to be on the bank site. So you want to make sure that the redirects are actually places you want your users to go. So usually what that means is they're relative, right? They're just leading /feedback rather than HTTP, right?
You won't pass a third-party security audit if you have unrestricted redirects.
Very true. Thank you. All right, so in summary, it's really hard to bolt on security to an application. So it's something you really want to think about. It's something you want to bring into your architecture, bring into your practices, and actually really get into the culture of your organization. We really talked about trade-offs a lot, right? Security and software, big trade-offs there. Usability versus security. You can have CAPTCHAs, you can reset your password every week in a bank, but that can annoy users, right? So it depends on your customers. You need to know exactly what type of customers they are, how much of that they can put up with, and actually how sensitive the data is you're protecting, right? If you're not a bank and you're not holding social security numbers, do you really need to do some of these things? So it's just something to think about. How do you stay secure? So it's hard enough to secure an application and get Burp to not complain about some of these things. How do you actually keep it going? You're releasing code every month. You're hot-fixing things as soon as they break. It's really hard. So you actually have to ingrain this into your organization, right? Get tools and knowledge into developers and QA's hands, and managers, anyone who's involved in the technology. The more you can do, the better. Another thing is automated security scans. So people probably do continuous integration. Why not get security tests in there, right? You can get Burp to save kind of a scan pattern, and every time you run a continuous integration test, fire Burp off at it, see what happens. It's free. Happens every time. You set it up once, and away you go. Another interesting idea is repository hooks. So things like we talked about the importance of unauthenticated controllers, so the pages that anyone can access. Why not, anytime anyone checks one in, fire off an email to a design review team, things like that. So use your tools, think about things, be smart. So it's really not that hard, though. With some good tools and some basic knowledge, it's not rocket science, and it's really important. We've talked about security. Vulnerabilities are on the rise. You hear about it in the news all the time. So it's really great you guys are here. I think it's awesome that people care about this. People should care about it, and spread the good word on security. So thanks very much. It's been fun. So just before Zach gets up here, just a few security resources that I like. OWASP, we talked about that a lot. Great lists, great code samples. I left the URL up there because I thought it was interesting that they put index.php in there, telling you they're using PHP. Or Eris said maybe they're using Java, and they're trying to throw you off. Burp Suite, awesome. I'd pay $300 for it. I say go for it. Hackers.org has a lot of really cool stuff. It's actually not maintained anymore, but there's a lot of relevant material there still. And the bottom two are two Google projects for security scanning. They don't have nice UIs like Burp, but they do kind of run. One of them runs as a proxy, and the other one just kind of spiders your site and applies different tests to it. So good tools for free from Google. Thanks.
Check. All right, thanks a lot, guys. And thank you, Matt. Matt put a ton of work into this presentation. You should just give it up for him one more time. It's not easy to kind of switch between 4 different windows and different screens and things like that, so that was a great job.
Thanks.
If you guys do have any questions, please ask them on the MeetUp site. We're constantly looking for feedback. So just a few housekeeping items, a bit of a shameless plug. We're growing like crazy, and that's a bit of an understatement. So if you know any developers, if you're interested in kind of finding a job in QA, product, dev, and this seems like a place that you want to work, or one of your friends would want to work, just email us at tech@achievers.com or talk to one of the developers or Achievers employees around the office, because we're constantly looking. Also, if you guys know what Hacker Nest is, they're probably one of the biggest tech groups in Toronto, MeetUp groups. We're hosting their next social here on November 26th. So if you go up to MeetUp or search Hacker Nest Toronto, you will find that meetup, and you can sign up, and that'll be here. They usually get about 200 attendees per event. So it's mainly for startups in the tech community, so if you're interested in that, please come out. Lastly, you've probably looked around and seen some awkward mustaches around. We are participating in November, so any donations you can give, we are providing drinks and talks for free, so the tip jar is out there. If you can give any donations to help out with our November cause, that would be awesome. It's not up here, but the last thing really is we're looking for feedback. So if there's, we've kind of been growing over the past 6 years, doubling every year, scaling an application to millions of users. We've learned a lot of things. If there's anything that you or people you know want to learn about from us, let us know on the MeetUp group, and we'll try to figure out how to do a talk. In the new year, a bunch of us are planning to take this whole Achievers Tech Meetup concept to the next level. Want to take it to more frequent talks, guest speakers, reaching out to the Toronto community. Want to make this thing massive. So any feedback you guys can give us, that'd be much appreciated. But thank you very much for coming out. We know we kept you long, but it's a very important topic. You guys are awesome. Have a couple drinks, hang out for a few minutes, and we'll see you next time.
If anybody has any questions, we'll just we'll talk out there. Grab Eris, grab myself, grab Kalen.
Cool. Thanks, guys.
Thanks. This. And throw that in. So we can see we didn't get a pop-up there, right? And the actual script tags are shown on the page, but actually didn't render. They didn't execute. So you got rid of the exploit there. So the next thing we talked about was filtering on the server. So in our feedback controller here, we can do some XSS filtering. In CodeIgniter, they have a nice library where you access the post data. You can pass in a true parameter and actually filter the data. This concept applies to all kinds of frameworks and languages. You just need to look for the same thing in your own environment. But really important that you do that. So we'll try that one again. So here it's even better, right? We remove the script tags. So CodeIgniter is actually configured right now to just display those words removed there, and everything's encoded, right? So we did 2 things there to prevent the problem. Cool? All right, we're going to move on. People are probably starting to get antsy and want another beer. So, on to another one called Crosssite Request Forgery. Have you guys heard of this one? Yeah? Awesome. It's kind of a hard one to describe, so we're going to do a demo after, but I'm going to try and put out some words that make it somewhat understandable. So it occurs when a website allows an authenticated user to perform a sensitive action, but doesn't verify that it's actually that user performing the action. Kind of complicated. Demo will make it clear. And this occurs because websites typically verify that a request came from an authorized, they don't verify that the request came from an authorized user. They only verify that it came from a browser of an authorized user, right? So it's not actually on the page that you're authorized in and operating on in the bank when you have a logged in session. So it assumes that the person being attacked is actually logged into the application that's being attacked. So it's kind of an interesting one. So somebody figures out that you bank at a certain bank. They know you're on that site a lot. So they launch exploits against that site. So people kind of have to know a little bit about who they're targeting. They need to know where they go. It's kind of it's a tough one. It's a tough one to pull off, but it's something that you really do need to watch out for.
Just to follow up on that, I want to make the point that if you bank at CIBC, then there could be a CIBC exploit, but let's say you bank at TD, it doesn't mean that an attacker isn't just going to blindly try transferring accounts or money from your CIBC account. So they don't have to necessarily know you. Remember, this is a dragnet. They just want people to show up to their site, and they're going to try the exploit. If only 1 in 100 works, well, that's still good enough for an attacker to still drain every CIBC visitor's account, even if they don't get any other bank's account.
Yeah.
So it's easier to exploit than somebody targeting you. So just remember, on the internet, it's not about you.
Yeah.
They're going for volume.
It's usually high impact. It's not like clickjacking. It's targeted against a whole bunch of people, and if one gets through, it has high impact. Grab millions of dollars. People do this to securebank.com because all the rich executives bank there, right? Like David Brennanson. So back to our example. Brennan Davidson loves the BlackBerry playbook. And he receives an intriguing email that has an ad for a playbook. He clicks on this ad, views the website, checks out the price, everything like that. Next day, logs into his bank account and finds that there's an unauthorized transaction in his account history. So let's kind of dive into that. All right, so the first thing to notice here is Brennan Davidson is still logged into the bank. Remember we said this is targeted on people who are authenticated against a website that's being targeted. So he's logged in. And he receives an email that links to this very interesting advertisement, right? BlackBerry playbook, amazing deals, lowest prices. He loves this stuff. So you'll see on the page here that there's a little iframe there. So this is another reason not to let your application be hosted in an iframe. And you'll see it's pointing to Super Secure Bank, which Brennan Davidson is also logged into at the time. So normally in this exploit, the iframe would be hidden, or there'd be other stuff going on, but I just wanted to show that this is what's happening here, right? We're on one website, and we're still talking in the same browser to Super Secure Bank. So if we go back into the account here, we'll see some debits. Brennan Davidson's in the negative now. This transaction just happened, $753. His balance went down by a whole lot of money. Hold for applause. Awesome. Okay, so we're going to go back to our slides for a second and talk about what's going on. So who knows what REST is? We got a few more bags here. I want to get rid of this stuff. Anybody? Somebody new?
I guess it's like a way to structure your APIs such that it makes use of the HTTP request flows and the different verbs like get, post.
Yep. Yep, so the term gets thrown around a lot. It actually stands for representational state transfer. I actually have to look that up because it doesn't mean anything to me. But one of the aspects of REST that we want to talk about here is actually using the right methods for what you're doing. So what do I mean by this? I mean a GET request is for getting data, and POST requests are for doing things like modifying data or creating new data. That sound familiar? Cool. So the iframe we just saw was obviously doing a GET request, right? So that was modifying the system. It was doing a transaction. It was debiting somebody's account. So that form actually has the wrong type of method on it. So in the form tag, you can actually just change method to post. That's better. You're doing an update, right? That's not really enough though, right? It gets us out of the iframe, but there are other things you can do, right? You can run server-side code and do a post from there over to super secure bank. You can do a get, anything like that in server-side code. So what we really need to do is we need a way of ensuring that the post actually came from the site, right? It came from the same browser as the authenticated user, but it didn't come from the same tab. It didn't come from the same page. So this is something that people call an XSRF cookie and token. So the scenario goes something like this. You load up a page, right? So you load up the page with the form where you're going to make a transaction. And on that get, you actually generate a token. So the token can be stored in something like a cookie or on the server side. And you also, in that form, you put the same generated token inside a hidden element. So what happens then is you post your form along, and on the server side, you compare that cookie value with the value that came through the form. If they don't match, you don't perform the action. You don't do the debit. People follow that? It's kind of a tough one to describe.
If we had visuals, would help immensely.
Cool. Well, we're getting there.
You said you put it in a hidden value form.
Yep.
How is it not visible when you look at the source?
It is, but the attacker doesn't have the source, right?
He's going to download the page. Look at the source.
Sorry?
He's going to download the page, look at the source, create his own form, and send it up.
But he doesn't have the token.
Each request
You generate one, right? So that generated token is in Brennan Davidson's form, right? You log in, you have a different one. You have to be, in Brennan's browser in his tab looking at the actual source to grab that. Sorry, I saw another hand in the back. I think it was Kalen.
Yeah. Does the token have to be exactly the same in the page as in your cookie, or can you hash it in certain ways so you can check it?
It's a good point. It's probably secure to have them different, have some transformation between the two. The one in the cookie and the one in the page are different, and only the server knows how to convert them and then match them up. Good point.
How would that?
How could it help?
Yeah.
How could it help?
Because somehow the attacker managed to get that
Yep.
the client side
Mm-hmm.
version of the token. You'd have that unless you hashed it in with the IP address or something.
Something like that. Yep. I can't think of an exact scenario here. Do you guys remember one?
It was, it's a variant of what gentleman's name you said like after the front suggested that it's an extra level of security that if you do manage to get the token, you don't know the transformation. If you get the cookie, the token in the form, you don't know the transformation of what the server's doing. An IP address is actually not secure enough because your IP address is easy to find out.
Yep.
You need to have a server side, whether it's under timestamp that works, whether it's just a password, something that only the server can know and nobody else can know.
Cool. Where are we at for time? 8 o'clock? Keep going along. So we're going to dive back into the application very quickly because somebody wanted a visual. So we'll go into the code here. Well, how long was it going to take before somebody told me that the slides were still up? All right. So back into the code for a second there. First thing you can see, in our code, we're processing gets, right? So we said we want to change that over to posts. We very quickly toggle our values here. Now our form is only processing posts coming through. We then would jump into the account view, and we would make sure that our form is actually posting. So this is a CodeIgniter tag that you're seeing here, but it basically just generates a form opening tag. So common form tag with the action and the method. And then it also generates that hidden input that we were talking about. So CodeIgniter takes care of right here, generating that hidden input. So the third thing we need to do is basically turn it on in the CodeIgniter config. So we're going to turn that on. Then we're going to go take a look at the form here. So Firebug, great tool. Inspect the code. We can see it's a post request now. And it also has this hidden token value. Everybody follow that? See how it works? Cool.
And while we are using CodeIgniter, that's what we use internally here at Achievers, every framework you can think of has something equivalent.
Yeah.
Don't think that, hey, I have to switch to CodeIgniter. While we highly recommend it, we love CodeIgniter. Every framework does have something.
It's true. These are all concepts that apply to everything. Finally, one last piece of functionality we wanted to check out was the address, right? So the bank has an address form. The user can create an address, update their address, and get some mail, get their bank statements. So we take a look at this form. So if you think about it, it looks like a user can only have one address, right? There's no create new address. There's just one per user. But we see up in the URL here, there's an interesting piece here. There's a 3. So what do we need that 3 for exactly? If one user has one address, it's a one-to-one relationship, we should need some kind of identifier. Go ahead.
If it's just like one, which is anybody can just know, there's only one field there, and they go from one field and they'll replace the data there.
Yep. So exactly. What we're doing here, we're going to toggle the data. Here's my address. I'm not logged in. I'm logged in as Brennan Davidson. I'm looking at my address.
Also, you're using sequential users, so 1, 2, 3, 4.
Yep, so this is just a user PK. So a couple things that are interesting here. PK, sequential, right? 1, 2, 3, 4, 5, easy to guess. Can use things like GUIDs as an identifier. If you do need them in a URL, it's good to go with something completely random. Cool. We're going to jump back to the slides and finish up. Kind of going overtime here. Good. Showing up? Cool. So, OWASP calls this insecure direct object reference, which is kind of a weird name. It's basically saying that you have access to stuff that you shouldn't have access to. Either it's not yours or it's not in your permissions to have access to it. So this is one of the things that I mentioned before that's really hard to test for. So it requires manual testing. It requires knowing the application, digging around, things like that. But Burp actually has some awesome tools for that. Remember, we saw the proxy. We intercepted the request. From there, you can actually play with parameters and then forward it on. And again, this is one of those things that you actually should be getting your third-party testers to spend their time on, right? Go ahead.
So you mentioned just randomizing that ID or making sure there's a random unique ID, but is just checking on the server side to see if that user owns that address, is that enough?
Yep. So that's true. So this is a weird case where it's kind of bad in two ways, right? It's not checking that it's the users, and it also, you only have one, right? You don't even need an identifier in this case. But you're right. If there is an identifier, what you really want to do is check that it actually belongs to the user. Follow? Good. So most of these are pretty silly, right? They're really, when you look at them, they're kind of dumb, but they happen all the time. Every application you go to, you play around with request parameters, and you can do things that you shouldn't be able to do. So really, my advice is just to slow down, use Burp, and actually, dive into your forms, test your application, and play around. So a couple final random tips before we get out of here and have another beer. File uploads are a very sensitive area. You do want to pay a lot of attention to these. So you have the ability to write a file to your system. You're letting your users upload files. You do want to be very careful about what types of files you're letting users upload. Do limit it to the minimum. And do check that on the server side. Checking stuff like the content type header isn't good enough. You want to check the extension. And you can dig even deeper and actually get into the contents of the file and verify it is what the extension says it is. Yep. Well, you can't do that in PHP, can you? I can't remember.